Welcome to the second video of the P2 chapter binomial theorem. On the screen is a starter to refresh your calculator memory with this notation n choose r. Pause the video now, give this a go, see if you can find all of these values using your calculator button NCR. Hopefully you remember it will look something like this. You might have to use a shift to get there, and I will start writing the answers up on the screen. Familiarity with Pascal's triangle means you might not need your calculator to do all of these. For example, down here, the 0th row, 0th term is a 1. But the 45th row, yes, I don't think I have that in my mind ready to go. 20th term of the 45th row, according to my calculator, is huge. I'm not even going to write that down. That's like 3 billion something something something. Okay, I'll let you get that one on your calculator. 9 choose 5 is 126. 19 choose 15 is 3,876. 19 choose 4 is the same, 3876, and that is because 19 minus 15 equals 4. So the 4th term and the 15th term occupy symmetrical positions to one another in the triangle. So that's the same number if you remember the symmetry of the triangle. That's why you get the same number there. And 6 choose 7, if you put that on your calculator, you should have a math error, because that is undefined. That's basically saying find the 7th term in a row that only has 6 terms. You can't do that. There isn't a 7th term. And this one, that was the one that was a very big number. Okay, in this video, it's going to be quite a short video, because basically it's everything we talked about in the previous video boiled down into a very simple formula. Apply the formula, get the answer. That's the basic idea in this video here. And the binomial expansion formula to expand any bracket a plus b to the power of n, where n is an integer, positive integer, is this. Remembering n here is part of the natural numbers, a positive integer, and this notation nr, the bracket, which you will see in the formula, that's why I've included it in the previous video, is the same as this notation, which is the one on your calculator probably, and both of those are denoting this formula here. So you can use this formula, and in the Edexcel formula booklet I'm pretty sure this is given to you as well, but generally speaking it'll be quicker and easier to use your calculator button. There are times, however, when this is useful. That'll come up probably in P4. So this is the information given in the Edexcel formula booklet, and that makes it quite an easy exam question. You don't need to remember it, but obviously you need to be able to apply it correctly. So we'll do an example of this and then finish the video there. And it's a short video again because what I'm going to do this example of is the same type of example as in the previous videos, except I'm not going to talk through the nth row and all the bits and pieces of it. I'm just simply going to apply the formula to show you how easy this is. As long as you do it correctly, obviously. The idea of it is easy. So a plus b to the n is given here in the question. Expand this. So my n is 5. You don't need to write all this out every time, but just for clarity, my a is 3. My b is negative 2x. and there. So these are the ones I'm using when I'm talking about a, n, and b inside this formula. So let's do it. Let's do the expansion. 3 minus 2x power 5 is equal to, first of all, a to the power of n. You don't have n choose 0 in this first term in the formula because that's always a 1. And you don't have b to the power of 0 because that's always a 1 as well. That's why you've got a to the power n by itself here. But you could, if you're being really formal, you could write that like this. And that would match what we were talking about in the previous video, but because that will always equal a to the n, they don't bother in the formula booklet. So that's why that might look a little different. So we've got 3 to the power of n, which is 5 in this example, plus n choose 1. Now if you put that on your calculator, you'll find that's a 5 times a to the n minus 1, so 3 to the 5 minus 1 is 4, times b, which is minus 2x, plus n choose 2, which in this case is 10. Put that on your calculator if you're not sure. 3 down a power cubed minus 2x upper power squared, plus n choose 4 is 5 times 3 down a power, oh no, what have I done? 1, 5, 10, it should be a 10, shouldn't it? Oh, I should always check the calculator. 3 squared minus 2x upper power 3, and then it's a 5 times 3 to the power 1 minus 2x to the power 4, and then it's a 1 on the end. And same reasoning over here, they don't actually write out n choose n because that will always be a 1, so there's a 1 on the end here, and 3 to the 0 is going to be a 1, so that's just minus 2x to the power 5. I hope you can see that very easily and quickly these expansions take a lot of writing space. It's not necessarily a quick question, but it should be a fairly straightforward question. And then you must remember to simplify. So we've got 3 to the power 5. If that's not too big of a number, do that. This is 243, that's fine. But if it's going to be a ridiculously large number, potentially you could just leave that in index form. 5 times 3 to the power 4 times minus 2 is minus 810. There's an x in that term. Plus 10 times 3 cubed times minus 2 squared, which is 4, is 1080. That is the x squared term. Next term, 10 plus 3 squared is 9, not plus, times 9. Oh, I've lost it. Times minus 8, 720, and that's a minus. And that's power 4. Nope, it's not. It's power 3. 5 times 3 times 2 to the power 4, 240. And that is power 4. And then 2 to the power 5 is 32, and that's a negative 32x power 5. And there we have our final answer. This is the expansion of this bracket here. I hope that you agree with me when I say that was probably faster than expanding a 5 bracket expansion. Certainly as you get to things like 7, 8, 9, 10 brackets, it's obviously much quicker to do this, although still very laborious. And an exam question won't use a power too high because it'll just take up too much time of your exam to answer it. But you could expect something like this, a power 5, power 6, power 7. When you're getting into very high powers, chances are you'll only be asked to do the first 3 in ascending order, or perhaps the first 3 in descending order, in which case it would be these 3. So be careful on the questions, and we'll look at some of the more interesting questions in the following videos. But for now, if you're using the Edexcel textbook, you can practice this formula using questions from exercise 4C. And maybe I'll see you in the next video.